Welcome to Department of Electronics and Telecommunication at Vidyalankar Institute of Technology. In this department, we have taken this new initiative to start our own YouTube channel. In this YouTube channel, we are going to upload all our experiments video, value-added course video, or any other important videos. This material will be available to all the students in Mumbai University, and this material will help students to enhance their learning not just in their classroom but even outside the classroom. I hope that everyone will like this our effort, and in case of any query, comments, anything, they can put it in comment box. Thank you.
Welcome to VLSI Lab. Today we are going to learn about the inverter. It is a CMOS inverter and it consists of a PMOS and an NMOS. Here, when we give input as 0, PMOS is on as you can see here and NMOS is off. That's why the VDD goes at the output and we get 1. When input is 1, as you can see here, PMOS is off and NMOS is on. As a result, the output will go to ground and we'll get output as 0. This is all about the circuit diagram of CMOS. As you all know, this is the circuit diagram and we have drawn the stick diagram according to that. For drawing that, we are going to draw 4 horizontal lines for VDD, P diffusion, N diffusion and ground. Now, you can see that the source of a PMOS is connected to VDD and that of NMOS is connected to ground. So, and I have numbered it accordingly like S1, D1, D2, S2. So, according to that, I have given S1 to VDD and S2 to ground. Now, as you can see, the output is between D1 and D2. I have connected D1 and D2 and given the output. And the input is given with the help of polysilicon, which is red. These are the colors which we are used to denote the following things. Now, as you have already seen the circuit diagram and the stick diagram, now let's look at its implementation on microwind. This is how the microwind window looks like. Now, go to File and select New. After doing that, go to File again and select the foundry and select 035 and open it. After doing that, you need it to be 1 lambda. In order to do that, click on the zoom in sign and click on the screen. You'll get 1 lambda. You will get the metals and all other stuff in this palette. Now, let's draw the metal. After drawing the metal, now let's draw the P diffusion according to the circuit diagram given here. As you can see, I have drawn the metal of 2 lambda and P diffusion of 4 lambda. This is done in order to connect the contact properly, which requires minimum 2 lambda. Now let's connect the metal and draw the contact for S. After doing that, the screen would look like this. Now let's draw the N well, which is extremely important as we have to keep at least 6 lambda distance from all the sides of the metal and the polysilicon and the P diffusion. Let's do that. As I told you, that is at least 6 lambda should be left. I have left some more distance so that I won't get any problem. After doing that, let's connect the polysilicon. Polysilicon should be at least 2 lambda long and it looks like this. I have extended the polysilicon downwards. Now, let's draw the N diffusion and the other metal and also give a contact to that according to the stick diagram which is here. This is how it looks. Now this is currently at 5 lambda so that I can show you properly. Now let's draw the output. This is how the complete layout of the stick diagram looks like. Now we have to give the input and output. For giving that, we have this symbols. This is for VDD. Just click there and click on this blue line and click in the envelope. Then this is used for the ground and give it on this blue line. Now, after doing that, we need one input and output. This clock signal gives the input and click on the polysilicon and assign it. And this I symbol that is visible node give us the output and assign it. Now this is how we are representing the CMOS inverter on microwave. Now let's run it and check are we getting the proper output or not. Here you can see that when input is 0, you are getting output as 1, and when input is 1, you are getting output as 0. Thus, it is working properly as an inverter. Now this is all about today's experiment, its circuit diagram, its stick diagram, and its representation on microwave. That's all for today. Thank you.